This is going to be navigating Google Cloud Platform. If this is not the session you're supposed to be in, you've waited a long time for the wrong thing. So let me give a quick intro. I am going to reveal little bits and pieces of information about me over the course of this talk, but I want to know who you guys are. So how many people in this room spend most of their time at work developing? Okay. How many spend most of their time working on systems, being a sysadmin? Okay. How many do both? Because you love DevOps? Your company won't hire more people. Okay. How many people tell developers or systems people what to do? Oh, shoot. All right, I got to cut a lot of jokes, which is fine. I got to cut a lot of manager jokes. It's fine because we're running short on time. All right. So my goal with this session is specifically to help developers and sysadmins to figure out, if you're new to GCP, to figure out how to find the solutions to your problems. I am not going to talk about us relative to competition too much. There's just too much to do, so I'm going to sort of take the baseline assumption that you're already on board. I understand that may not be the case, but it is a pleasant fiction that we'll just all sort of share together and we'll be fine. My other goal is to not show off our org chart too much, which is difficult because most of our leadership are, in fact, blue hexagons with weird figures on their faces. Luckily, they've lucked into a job here where they can be that. We have a lot of products. We have a lot of things, and they all have names, and those names may or may not be descriptive of what they do, cause reasons, right? So my goal is to get you from looking at this big chart and feeling like this to being able to find what it is that you want to talk about, what you want to use. Also, some of this is more complex than other parts of it. What computing you use? What is going on? There we go. Whoever's messing with it, stop. Some of this is more complex than other things. So I am going to start talking about computing. I'm an application developer by trade, and so I'm going to spend a lot of time talking about processing and doing things. Then I'm going to go into networking, storage. I will talk a little bit about big data. But I will warn you that as an application developer, I don't do a lot of big data, so you're going to get C+ answers if you probe me, which we may not have time for, which is kind of good. I shouldn't have admitted that. We have also, we're going to talk about administration and development, and then finally, because we have to do it by law, we're at a Google conference, we should talk about machine learning. So I am going to focus on computing and storage. Because there are difficult questions to answer in those two spaces, like which thing should I use for this? Whereas with networking, administration, development, it's a lot of like, let me find the right tool for this particular thing. What's its name? And then finally, machine learning. You're going to hear a lot about machine learning at this conference. So I feel like I can kind of give a very, I don't have to go too deep with machine learning, even though, with any of these icons we had up, each one of these could be an hour-long talk, or more, or a whole conference, depending on what we're talking about. So with that, I'm going to get into computing or doing things. So when you talk about computing, you're usually talking about one of three things in this space. Talking about virtual machines. So I have stuff that runs somewhere else. I would like it to run here. How do I get it to run here? We have containers, since everything is moving to containers, as we are completely told constantly by the zeitgeist. And then finally, serverless. Serverless is for, we don't want to deal with the underlying infrastructure, we just want to write code and push it somewhere. Now, those of you that have been following the space for a while, you may know that we talked a lot about platform as a service a couple years ago. And the dirty secret that no one's going to tell you is that serverless is platform as a service, but for people who have kind of fallen into the Gartner Trough of disillusionment, so we got to call it serverless, so you're not afraid of it. But serverless is another path, and we'll talk about our solutions there. So let us start with our virtual machines. They're pretty straightforward. They are virtual machines. You can choose one from 64 processors. You can go all the way to 0.6 gigs of RAM, all the way up to 416. And basically, you're bound by how many processors you use. You have to use a minimum of 0.9 to a maximum of 6.5 gigs per processor. Those of you that are looking at the slides carefully and doing math, that doesn't add up. We have one or two configurations that have less than 0.9 gigs of RAM. You add disks to it. You can add simple persistent storage. You can add SSDs. You can add RAM disks. You can also, I don't know if we announced that yet, so I won't add that. We also have, you can build off of our pre-configured images, so Debian, Ubuntu, Red Hat, other flavors of Linux and Windows. You can customize those images and save them, or you can even upload your own images. And we like to say that our VMs spin up in tens of seconds. What do we mean by that? We mean that when you're in your hotel room testing the night before, they spin up in 20 seconds. When you're in front of a crowd of people, they spin up in 40. I don't know how they know. I think it would be in their best interest to spin up quickly in front of guests, but they do what they do. And you'll see that in a minute. Now, I just want a blank VM. I want to build it myself. It's fine, you get that. But a lot of times people want to fool around with something already built, like I want a WordPress install. I want a MongoDB set up already for me. So we have a tool that can do that called Cloud Launcher. We have images that are available. So for many and most common software packages, you're just going to be able to go there and load them up. Now, we don't manage them for you after you run them in Cloud Launcher. It's as if basically you spun up a VM, did all the configuration work, and you're at the same spot. So it's just a jump start. So I'm going to quickly show a demo of Compute Engine, because demos are fun. So this is Compute Engine. This is the interface for it. I'm going to go ahead and create an instance and show you some of the options here. So I'm going to customize this. I'm going to build it with as many cores as I want, a little less memory. And this is great. Like, we have pre-built sets. If you go back to the basic view, you can set very particular things. But let's say you need somewhere between 8 and 16 cores. You can dial that in very specifically. So I'll go to 12. There we go. I can choose my image, I can do all that. I'm going to go and create. Now, we'll see if it creates in time, but I'm going to use the image Julia Child last night. Yes, I used Julia Child as a verb. And you'll see that I didn't pull down any certs. I didn't fire up my own terminal. I just went through the browser, and I am browsing directly in. Now, which one's going to come up first, the SSH? The instance popped green, so it was ready. We weren't watching it fully, so it kind of was like, okay, maybe I'll spin up fast. All right, and there we are. And now our command line SSH, I can do whatever I want on this VM. That quick, that easy. All right, thank you. Yeah, I love SSH in the browser. It is life-changing when you get it. All right, so now we're going to move on to containers. How many people here are fooling around with containers already? Okay, how many are running them in production? Okay. How many have said the word Docker in a parking lot and a conference sprung up around you? It happens, all right? So good, all right, so containers is another path for virtualization, is an alternative to virtualization. Instead of carving off a whole machine and using all of the resources dedicated to a VM, you basically fool all your hosts, all your containers into thinking they're the only machine running. And so you can split off processes and start things up really, really quickly for those that aren't as full-on containers yet. That was a very quick explanation of containers. So, containers at Google. First thing we talk about is Container Engine, which is managed Kubernetes, which leads to the obvious question, Kubernetes. Kubernetes is a container orchestration system, meaning if you want to just spin up one container, Docker's great. If you want to spin up gigantic sets of interconnected containers that need complex networking that goes between them to allocate resources and services between them, it gets complicated and big. So here's like a 3-tier app, right? I want to spin up a single instance of a database that we would call what would we call it? I would call it a pet set, but we call it something else now. But it's a pet, right? Like you just want one. And then I've got the API layer, which is multiple versions, multiple processes running for the API layer, and a front layer. All of these are wired together. If one of them goes down, it will, because I said I want 4 of the middle layer, it's going to make sure that there are always 4 running. So if one goes down, it will resurrect. And this allows you to organize your containers into what we call workloads. Now, workload could be microservice, which is a lot of what containers have been known for, but it could also be things like scheduled jobs or batch jobs, anything where you need to spin up large amounts or small amounts of the same process over and over again, containers and Kubernetes could be a good solution for you. Now, this is running on top of Kubernetes. But from a systems perspective, here's what you have to do to run Kubernetes. You have to build up your machine. You have to pick the OS, pick where you're going to run it on-prem, another cloud provider, or us. We would love to have your business. And then you have to install Kubernetes on them. And then once you install Kubernetes, you have to set up a network. You have to make sure that network has DNS, which helps with service discovery. You then set up logging and monitoring, because those things are the sorts of things we like to know about our servers, that stuff is happening. Maybe you're not cool with the fact that they resurrect and go away, the containers. So you want to add some persistent storage. And now that you have your Kubernetes cluster up, you have to make sure you maintain the version of Kubernetes and the OS, and make sure you patch the OS, and handle all of those updates and all of that maintenance. Or there's this little box called Container Engine, and there's like a little box right there that says create a container cluster for me, and that's all you have to do. It's like all of that thing, all of that explanation I did, or you just press that button. So we like to say that, I was going to do a quick demo of Container Engine. See, I have a terminal up and ready. All right, so I'm just going to, I'm going to run one command. I'm going to show you this visualizer. So this visualizer is right now looking at the containers that are running on my Kubernetes cluster. I'm going to run a make command to git deploy, and we should see, assuming the network gods have been, there we go, the network gods have been appeased. And so I am building multiple systems at the same time. I am building 4 database servers that power 7 front ends, 2 copies of Drupal, 1 copy of a custom app, a Node.js app, WordPress, and one other, Zen developer server. So I just spun all of this up. All of these machines got their networking, their backend, and all spun from nothing. And now the dark green ones are going to get IP addresses. I don't think I have enough time to dig into them, but it's important to note that those are public, and the light green ones, the SQL servers, we would like them to not be public, and we can do that. So in a very quick way, one of my apps is up, so I'm just going to click to see if it's working. No. All right, ditch. Don't have enough time. I think something's weird in the browser there. Okay, so that puts us here. Okay, so that was just a quick launching up a whole bunch of different workloads on Kubernetes. I can do it fast, I can do it scripted. Kubernetes is what we call, Container Engine is managed Kubernetes, or containers as a service. We have smart defaults set for monitoring and logging, DNS and service discovery, and we can also auto-scale. So you can set up your Kubernetes cluster on GKE to basically, as your load goes up, spin up more hardware resources in order to handle it, or spin down, as the case may be. And so that's Container Engine. Now, another way we have of dealing with containers is something called App Engine Flexible Environment. Now, App Engine, when we talk about App Engine, we talk about it usually in terms of serverless, because it's a platform as a service. You don't ever really interact with the underlying infrastructure. But under the covers, App Engine Flexible, not App Engine Standard, but App Engine Flexible is running Docker. So you can flip a bit and say runtime equals custom, and then you can put whatever Docker file you want, and we will run it as an App Engine app. Now, what that buys you is connecting to a lot of our resources, and you get auto-scaling out of the box from 1 to however big you need to grow. And then you get one endpoint for service, so a lot of the work of setting up a service kind of goes out, you don't have to do it. So that is App Engine Flexible Environment. There are 2 helpers to help you deal with containers in Google Cloud Platform. We have Container Registry and Container Builder. Container Registry is a storage repository for Docker images. So you build your images, you push them up to the registry, and then they're behind our security, so you can lock them down with your Google Cloud account, and you can pull them from Container Engine or App Engine Flexible or a Docker client running on your own machine. And in fact, what I usually do is I push stuff up to Container Registry, I will be in production on Kubernetes, but in development, I will develop on Docker. And so I can use the same image in the same builds in both places. Container Builder is brand new, as in Monday it came out. It is a service, if you're doing a lot of work on containers, you reach a point where you need to build a build infrastructure to make sure that your builds are consistent and you're going through whatever continuous integration tools you have. Container Builder will just do that for you. And it can integrate with other CI systems and other repositories, or you will just build it and store it for you on Container Registry and speed up that whole process. So, all right, that's containers. Now we'll move on to our friend serverless. Serverless, we have our friend App Engine Flexible Runtime. And now I said it was a container technology, and it is. But if you don't flip the switch, you're going to use one of our runtimes instead of your own Docker file. And the runtime under the covers is a Docker file that we built specifically for this. We have set languages built already, and we're working on adding more, but it's Java 8, Python 2.7 and 3.5, Node.js, Ruby, PHP, and Go. Version numbers are a little muddled right now because I can't remember if we released the thing or not. The big differentiator here is that under the covers, like I said, it is Docker, so you can add extra things to our Docker file. So you can add extra software, add extra configuration, and really open up the capabilities of your machine. Your application. As opposed to App Engine standard runtime, which is much more locked down in terms of what languages you can use. Python 2.7, Java 7, PHP 5.5, Go 1.6 or 8. Can't remember where it's at. The abilities are much more constrained. For example, PHP you can extend in C if you need to, normally, but on App Engine standard you can't do that. You can do that on Flex, but on standard you can't add extra code. You can add more PHP as long as your extensions are in PHP. It'll work fine. But once you try to dip out of PHP, it won't work, or Java, or Python, or Go. Now, what do you get for this constraint? You get incredibly rapid scaling. And I'm going to show that off in a second to kind of make it clear why the scaling really is rapid and why you might use it. The other thing is it scales down to 0. Flex will scale down to 1 instance and have 1 instance responding to requests all the time. App Engine Standard will scale down to 0 and will not charge you while it's at 0, which is kind of a nice feature. Finally, we have Cloud Functions, which we're really excited to be talking about. There are demos out in the showcase area that talk about this. App Engine, you're abstracted to an app, right? And you move an app from place to place. But the unit of abstraction with functions is a function. Why does that make sense? Well, let's say I've got a mobile app or some other thing that all the logic is somewhere else, and I just need to do one thing. This is the halcyon, perfect example of this. I just want to send mail from my mobile app. You could write some code, build an application, set up routing so that your API is easily called and locked behind security and everything so that app can send a mail. You could build an application for it. Or with Cloud Functions, you just write the one function that sends the mail, and it'll create an endpoint for you so you can attach to your app, and so you don't have to build an entire application just to serve up one function. So that is the main differentiator there, and it is JavaScript, Node.js only at the moment. So I promised a demo of App Engine in action, taking load. So, here's my Kubernetes app. It decided to load. Okay. So I have here a set of 10 VMs, Compute Engine VMs, and they're going to hit that URL. Please, you can hit the URL. Don't hit that URL. No, don't, because you'll break the whole from cold. We're going to see how App Engine scales. You can hit it after I'm done the demo if that's your thing. So I'm going to go ahead and run one make command, and I'll explain what I'm doing. I'm instructing each one of my VMs to send 1,000 hits at that URL, and to do it concurrently at 50 apiece, so a 500 QPS query. So I'm going to run that. We're going to switch back over here. Someone hit the URL. Someone did it. That's all right. You'll still see some magic. So in a moment, you see as soon as Compute Engine gets the traffic and starts sending it, they start bouncing. And that is App Engine spinning up instances of my application in order to handle the load that's coming in. And basically what will happen is each instance can handle a certain amount of traffic at once, and then say, hey, I'm a little peg, and we'll start spinning up more instances to take it. That's how quickly we spin up instances in order to deal with your traffic. And that's why the whole scale to zero is awesome, right? Because it quickly responds when you have traffic, but then when we don't have traffic, it starts spinning down instances, and 3 of you, your queues, 3 of you, 4. All right, well now I don't care. Now you can just ping it away all you want. And you can see the numbers go up in real time. Yeah, you're really doing that. You're really hitting the URL. Oh, all right. I've challenged people. They're feeling feisty. So that's just a quick demo of what App Engine can do. And with that, we kind of get to the end of that section. We are done all our computing technology. You should have a good idea of where to do containers, where to do serverless, what the difference between the serverless are, and that our VMs are pretty quick. So with that, I'm going to change gears, and this is going to be more just explaining things. Networking is incredibly complex, but can't really get into it in this, so I'm just going to tell you where to look for certain things. So networking tends to be about connection, security, and availability. People are looking to connect to us. First thing is we have something called the virtual network, cloud virtual network, that allows you to build your own private networks for your project and set up custom routes to non-Google locations. We also have this thing called Cloud Interconnect, which is kind of cool. You directly peer to Google. If you are doing a lot of business with us and you're transferring a lot of data back from your network to our network, it may be something that would be cost effective for you. Security, from a networking perspective, 2 major ways we look at this. VPN, which is gateway to gateway only for us. So this isn't for equipping road warriors with a connection to your network. This is for connecting 2 or more networks via a secure tunnel. And you can use any IPsec compliant gateway, but the idea here is you have machines at us, machines on-prem, machines at Amazon or Azure that you want to connect together. You can use this to do it. Firewall, it's a firewall. Like, you set up rules, it's nothing too crazy. But the reason why I bring it here is because this is about discovering things. When I first started using Compute Engine, one of the problems I had was figuring out, how the hell do I open up a port? I just want to open up some random port, as one does. And you have to basically go through networking to find the firewall settings to create firewall rules that you can then apply in Compute Engine. But it is maybe less than intuitive the first time you come to it, so I want to make sure to call it out. Look in the networking section of our app, of our console, is what we call it, to find these things. At some point, someone says, well, I want something that you don't have. What can I do? Well, you can, in Compute Engine, build anything you want by hand. And we actually have, in Cloud Launcher, VM setups for Barracuda, Brocade, Cloudflare, and a whole bunch of others. I clearly went alphabetical in my list. And you can build these and you can manage them. We don't manage these for you, but you absolutely can do that. Now, talking about availability, we have Cloud CDN, which you activate. The interface for it is actually through our load balancers, which I'll talk about in a second. And they basically uses HTTP headers in order to determine cacheability. You can do edge caching and invalidation and preloading and all the sorts of things you do with content. If you want to do more complex things, this is not the solution for you. This is not meant to be a comprehensive solution. People want this as part of a basic cloud package. We offer it. If you need more complex things, we have partners that are more than happy to talk to you about doing more complex things with caching with us and them. So next is DNS. This is interesting in that it is the only thing I've ever seen where we promise 100% at Google that we promise 100% availability. Our SLA is 100% availability, and I had to double. Did it round up somewhere? No, it's 100% availability for our DNS servers. So something to keep in mind. That's interesting. And then finally, our load balancers. A lot of people talk about load balancers in terms of L4 versus L7. We don't. We talk about HTTP and SSL load balancers, which do what you'd imagine they do. Internal is for load balancing traffic that would not leave our network. So a lot of times people want load balancing of internal services. We can now do that. And then finally, network load balancing is for balancing more than just HTTP traffic. All right, my first auctioneer section is done. So now I'm going to move on to storage, where go a little bit deeper and talk about why you would use one versus the other and whatnot. So with storage, we tend to be thinking along 3 lines. Files. I was heavily encouraged to use the word blob, but as an adult human, I really don't want to get up on a stage and say the word blob over and over again, but I did, so they tricked me, so they won. But think of this in terms of documents, of images, of videos, of audio files. Like, they're files. They're not, you use the word unstructured. They have structure. They're not related to each other that much. As opposed to databases where you have data that all looks the same, it's all telling the same story, and is all supposed to be lined up and easy to aggregate and talk to it together. I also think of this as application data as opposed to files, but semantics vary. Then finally, big data, which under the covers is really just one of the other two that's gotten so big that to get insight out of it, you need to run special processes on it. So big data is just any one of these things that's grown out of control. So we'll start with file storage. You're storing files. If you are used to some other provider that calls it S3, this is the equivalent to that. They get a little touchy about us, another brand, so I'm being recorded, so I'm nervous. So cloud storage is the S3 equivalent. We have one set of interfaces, so you deal only with cloud storage. You create a bucket, and the way to deal with that bucket is the same no matter what type of storage you're talking about. So when you create it, you create a bucket, and that's it. But we have several types: multi-regional, regional, nearline, and cold line. I will describe why you'd want to use one versus the other. So thinking about file, we kind of have 3 areas that we look at it. Public content that we're going to share with the world, we're going to share with our customers. Process data, we have data that we need to run analysis on. It doesn't need to be global. I don't need to share it with people. I want it to be close to the servers that are going to be doing the work. So regional is fine. It's in the same data centers, in the same data location. And then long-term storage is for stuff that, at the end of the day, we really hope we never see again, right? So things like backups and disaster recovery related data and compliance, right? And people hate compliance because what did you do shortly before you pulled in a whole bunch of compliance data? You had a conversation with a lawyer, right? So we don't want to touch this stuff. We need to keep it, but we don't ever want to touch it. So we want it to be as cheap as possible. So kind of putting that together, we'll start at the top and go to the bottom, name the type. We have public storage. For us, it's 99.939 plus a 5 availability. It's geo-redundant. This is good for world access content, things like websites, streaming video, streaming audio, gaming, mobile. And it's 2.6 cents per gigabyte per month, and this we call multi-region. For process data, we have a little less available. Makes sense because it's not geo-redundant. And it's accessed by your system, so you need to run big data work, big data jobs. You want this data to only live in one place and be pulled in by owning a set of servers in one geographic location. We do that for you. It is cheaper. It's 2 cents per gigabyte per month. We call it regional. Then we have 2 options in long-term storage. It's not as available. Your time to first byte, we measure in seconds instead of milliseconds, but you'll still get good throughput pulling the stuff down. You have to keep it on us for 30 days minimal. Now, that doesn't mean you have to keep it on us for 30 days minimal, right? If you want to delete it, it's fine. It deletes, so it's fine. We're still going to charge you for it, right? That's the 30-day minimum. And it's for backup and maybe long-tail multimedia, right? You have a video file that's looked at every 6 months. Putting it in cold storage and making it public from cold storage, it's fine because it's stored really cheaply because it's a video file, so it's bigger. Storage cost is 1 cent per gigabyte per month, but if you retrieve it, we're going to charge a retrieval cost for it that goes on top and is 1 cent per gigabyte per month. And our last option is cold line, which is just as available, but you have to store it for 90 days instead of 30 days. And again, delete it, it's fine. It's just about the charging. And it's for disaster recovery and for compliance data. And it is the cheapest storage we have at 0.7 cents per gigabyte per month. but retrieving it is slightly, like we're incentivizing you to not pull it out too often. It's 5 cents per gigabyte per month. That's cold line. All right, so we move on to application data, and we move on to one of the giant fights of our day. SQL versus NoSQL. We could have a whole session, a whole conference, a whole fleet of events that just hold conferences and sell books and online seminars about this topic. So I'm not choosing a fight. I'm saying we have NoSQL and we have SQL. It's fine, we have both, and we welcome both, even if we have our favorites. I like SQL. But we have good options on both. So I'm going to talk first about SQL. We have Cloud SQL, which is a traditional SQL server. It is based on our VMs, so it is vertically scalable to the size of our VMs. But you don't ever actually, you won't see the VM in your list of compute engine instances. We manage the OS entirely for you. And we do things like managing the backups, and we make setting up replication sets and opening up network connections pretty easy. You'll see there that it says types, but there's only MySQL as a type. You can assume that up to this date, we've only had one type, and perhaps we have another type, and that I got told we didn't announce it yet, so I pulled it. So keep your eyes peeled for the rest of next. You will find another type there. I figured you guys are smart, you'll figure it out, so I figured I'd cop to it. I can't say it, but I can't tell you to not look for it. Our other option is Cloud Spanner. Now, Cloud Spanner is for structured data, like traditionally what you'd store in SQL. We advertise it as both highly available and strongly consistent, which the CAP theorem says, if you guys are into this sort of thing, CAP theorem says that's impossible. So what we did is we found the guy that wrote the CAP theorem, hired him, made him a VP, and he came out and was like, yeah, that's cool, you can say that. Which is, again, this is a superficial session. It's a very abbreviated version of the way it happened. But long story short, if you want to dive into this topic and why we say it's both, and if that's something you feel strongly about, please see me afterwards. I'm happy to dig deeper into it. But long story short says we call it highly available and strongly consistent. It's globally distributed and it's horizontally scalable, which is great when Cloud SQL starts hitting its vertical limit. Having a horizontal piece to this is really helpful. Now, it's important to note that there's a large price differential between these two. And the reason I say this is because I just helped a startup who had been fooling around with Spanner, not realizing that it's a BMW, not a Volkswagen, right? And so I would say if you don't have the need for it, don't. If it's not solving the problem you're having, you're not running into horizontal scaling problems, and you don't need incredibly high latency. Make sure you read all the fine print before you spin it up. If you need it, it's awesome. If you don't need it, it's a giant bill. It's about I said I wouldn't get into pricing, but it's more expensive. The next option is Cloud Datastore. Cloud Datastore is a document-based NoSQL store. It's indexable. And you can make it pretty giant. We have customers that store a lot of data in this. We also have this thing called Cloud Bigtable, which if you guys follow our papers, we had Bigtable. We made a paper about it, but we didn't release it. And so now there's this thing called HBase. HBase is the open source version of it, and now we need a Cloud Bigtable, which we released, to sort of work with it. So it is a columnar low latency database. Not a lot of people use it in an application, but I leave it here because there are some people that see it as a next step for them. It's important to note that this one also, like Cloud Spanner, you really need it. We say that until you are storing a terabyte of database information, Bigtable is not going to be cost effective for you. So keep that in mind. All right. Okay, so I talked about files, and I talked about databases, and now I'm going to talk about big data. So where do you store big data on Google Cloud Platform? In all of these. All of these can, if you've got 2 terabytes of data in MySQL, it's hard to argue that's like small data, right? So any one of these is our storage for big data, What you're really concerned about with big data is tools. So let's talk about some of the tools. Anybody here played with BigQuery? Okay, a couple people. All right, BigQuery is sort of, it's magic, especially if you're not a big data person and you're like, how did you do that? You pipe in semi-structured to structured data. You can analyze it very quickly, and you can use SQL to do it. And that's sort of its special sauce. With most big data jobs, what you're going to do is you're going to build some sort of job to analyze your data. You're going to throw as much computing resources as you can at it, and you get the answer back when it's done processing all the data. BigQuery is different in that, well, that whole piece of you throw as much computing resources as you have at it, like, well, it's us throwing our computing resources at it. And so we keep a whole bunch of machines just ready to go to process BigQuery queries. So we can usually see for billions of rows performance in under, like, depending on what you're doing, you can get performance of a second for multi-billion row queries. And in fact, I'm going to show this off. So let's see, here we are, BigQuery. So a friend of mine has in their BigQuery storage every Wikipedia request ever made, like the logs for all of Wikipedia. And so every time someone went to Tom Hanks's Wikipedia page, we flip a counter. So we have those logs. So that's a lot. That's a lot of data. So I'm going to go, nope, that's the wrong one, formatted, unformatted. Here's a query. I'm going to edit it so I can run it. You'll see it's SQL, just like sort of you're mostly used to running, and I'm going to run the query. And it's going to come back in 1 second, and you'll see that's because it's cached. I was cheating. So I'm going to uncache it, just so that we see. I'll run the query. And it's going to take 11 seconds. I'm calling it. Might take 16, but I think it's going to take 11. Come on, a lot of time with me upstage. Come on. Or you've been talking to Compute Engine, haven't you? It's been, oh, there we go, 17 seconds. So 17 seconds, we processed just under a terabyte of data to get this number. This number at the bottom is very hard to read. I'm going to bump it up in a second, but first what I'm going to do is actually put commas in it, because otherwise I can't read it. And I would hope you guys can. If you can parse that number without commas, I'd be impressed. Here we go. We're going to run this query. No, that's the wrong one. Yes, cancel. Sorry. There we go. Sorry. There we go. All right, now I'll run the query. This will take 20 seconds, and it'll actually format it. But long story short, and I'll show the explanation of all of this when it's done. We're going to go through another, 9.9 terabytes of data. And it's going to go about 20 seconds this time. I'm going to be pessimistic. We're not caching because I turned off the caching. So there we go, 19 seconds, just to make me wrong. So that number, if you can see it, is we calculated, we added up 1,190,543,847,386 requests to Wikipedia for 2 years, looking at the query there. That's kind of awesome. And if we look at what it did under the covers, I got to shrink down my screen. We can actually see an explanation, and we can see what it did is that it started out with 130 billion rows of data from all the Wikipedia entries it has. You see here it is. It's all the requests of all the tables it called. And then it shrunk it down to 65,000, so it did a map reduce on it. And then we reduced it again to the one answer of that. We did all of that in 20 seconds. We counted up to 1 trillion, processing 130 billion rows of data. Is that okay? Yeah? All right. Okay. Tough crowd. Lunch is looming, I know. So big data, not storage. PubSub, publisher subscriber model, basically allows you to communicate between multiple pieces of our platform. Use it a lot when using the database tools I'm about to talk about. We can easily handle 1 million messages per second, meaning if you're going to do less than 1 million messages per second, you don't really have to talk to us. If you're doing more than 1 million, we just like a heads up. So keep that in mind if you're starting to move over and do lots of messaging on our platform. Data flow. Anybody here use Apache Beam? No. I saw one. Apache Beam, but managed. So does data transformation for you. You line up your workload, transfer the data as it goes into an analysis system, and you can repeat it multiple times. And then Dataproc, which is managed Spark and Hadoop, with the added benefit of allowing auto-scaling. So it makes building out your jobs and throwing more resources at it much more easy. Important to note, just as a side note, that between cloud storage and cloud PubSub, you can interconnect any one of the rest of our products. So if you're building an app on App Engine and you want to send it to our machine learning APIs, like say the Vision API deals with images, you can directly send the image to the API, but you have to base 64 encode it, and it's sort of not a very efficient process. Or you can store it in cloud storage and then tell Cloud Vision API, hey, I've got a file for you, and it'll handle it. So almost any one of these tools can be connected to any of the other tools through these two. So important to keep in mind as you start to solve problems like how do I build out systems, this is one way to do it. What if we need something we don't offer, right? We have non-managed storage solutions that you can build by hand, right? Or you can go to Cloud Launcher and get Cassandra, Redis, Mongo, CouchDB, or others. Did not go alphabetically this time. I don't know what my order of preference was. All right, so that is storage. Hopefully that gives you a good indication of where you're going to find the storage you need. We're coming in the home stretch, and we're going to administrations. So administration is usually worried about three things: reporting, security, and configuration. If you've noticed, I like to make 3 thing slides. You'll see that theme throughout here. Reporting, Stackdriver. Now you will notice we'll call a whole bunch of tools we have Stackdriver, which is weird because it's Google Cloud Platform. Why is it Stackdriver? We do that so that you kind of can so it's easy to wrap your mind around the idea that Stackdriver is actually a hybrid or cross-cloud solution. So you can run it on us, and we set it up automatically for you, but on AWS, most of our products for reporting have like a one-click or a very easy solution to get it running and spin it up on Amazon. And then on-prem, because all of this has an API, you can extend between the API that we have and the SDK, you can write your own tools that'll talk to these things. So we have got logging, we've got monitoring, right? You can build up alerts based on things you're used to, uptime checks, build-in metrics, and so forth. For security, this is important for a lot of companies. We now have Cloud IAM, so I'm not going to. It's like it could be its own talk too. So I'm not going to dig too deep into it, but just find Cloud IAM. You can create accounts that you then can assign to roles and permissions, then use to lock down various pieces of your account. Sorry, of your infrastructure. So finally, configuration. You're going to do most of your configuration probably command line, probably using the gcloud or the gsutil tool. Gcloud will do almost everything, but if you actually want to deal with files on cloud storage, you're going to want to use gsutil because it's sort of gcloud is for management of the systems. gsutil is actually for reading and writing from cloud storage. We also have an API with an SDK for most languages. They give you REST endpoints that are functionally equivalent to gcloud. So you can build your own solutions in whatever language you want and also call them similar to gcloud. And then finally, deployment manager. If you like writing massive YAML files, as we all do, you can write out your entire environment in YAML and then reproduce it either on your own project or new projects with network configurations, with what servers are set up, with VMs, what Kubernetes setup you have. And this is actually how Cloud Launcher works. So we use it internally, and it is available to you. All right, moving on to development. Developers in general, we think about coding, we think about reporting sometimes, and we like using services because then we don't have to write it. So development, we have the SDK. Important to note that most of the things you want to do, you can do through gcloud. If you're using App Engine, you also want to make sure you have app config because the PMs tell me that gcloud can do everything that app config can do, but they're lying. Or they're wrong, but they're lying. Plugins. For any IDE you have, we can plug into most of them with tools that help, basic basic code intelligence of our commands and our APIs. And then others I clearly ran out of my 3-tiered icon system. We have cloud source repository, so we have managed Git that is locked with our security that you set up through Cloud IAM, and it works with one of our other tools that I'll talk about in a second, cloud debugging. So moving on to reporting, we have Stackdriver Trace, which is installed automatically on App Engine and on load balancers. You can enable it through an SDK and a couple of other environments. And I'll just show it because it's kind of cool. If you guys have seen any of the showcase demos, which are up on the 3rd floor, there's one with a giant pi symbol where you spin up and build pi. You crunch 100 million digits of pi in a very short period of time. So that application I was having some trouble with. And I was looking into what was going on. And you'll see down here, I get pretty basic information about what's going on. The whole request took 92 milliseconds. I made a call to the identity service, and then I went and made a call to another API. I can then click on that button to show the logs to see what was going on at the same time. And I can see distribution for how long that same request took, the many different times it was taken. And I kind of see, like, oh, there was an anomaly versus, oh, there's a whole bunch that are taking a long time, there's a problem. So that is Trace. It's really, really great when you start digging into it. There's also error reporting for aggregating either log data or stuff that you send directly to the API. It is also really helpful to see, like, is this an anomalous error, or is this something that I now need to take care of? Debugging, again, if you use cloud repos and this, you can actually step debug into your code and then go directly into your code on cloud repo for stuff running in production, if you are brave enough and bold enough to do that. It's available on App Engine and Compute Engine in a couple different runtimes. So services, we have all of these services, and not just us, right? Like Cloud has a bunch. We also have ads and G Suite and YouTube and other things. The point I want to get across to you here is that most of the time you need to set up some sort of certificate or some sort of security between these services and your cloud project. However, we have this feature called default credentials, and they work on App Engine and Compute Engine out of the box. And it's beautiful. Because all you have to do is, instead of setting up a whole set of certificates and putting them in your code and storing them and worrying about managing that and not accidentally adding them to your Git repo, you can just say, give me the default credentials to call this service, and that's all you have to do. So it makes dealing with these services a lot easier. So something to keep in mind. All right. I'm going to finish with machine learning. I am running OK on time. And so machine learning tends to be about 3 things: using models, creating models, or extending models. So we have a lot of models that you can use: Vision API for images, natural language API for text, speech API, translation API. Use them, they're awesome. If you want to take a next step and not use a model but train models, you want to learn cloud. You want to use Cloud ML Engine. It is managed TensorFlow, which you should be asking, what flow? TensorFlow is an open source ML library that allows you to create portable models that you can train in one place and also train in other places. So the idea here is that you can train your model with varying levels of GPU and CPU power, and it's okay because you can move them from place to place. So when we get back to machine learning, Cloud ML Engine, we just changed the name, so I apologize for bobbling it. It's managed TensorFlow, which does a whole lot of self-tuning, and it's portable. So you can create a model on your laptop and move it to Cloud ML and have it run in Cloud ML with much more resources that then get self-tuned. So that's it. Oh, so conclusions. So hopefully, after all of this, we're now putting the table back up that we flipped over when we saw this. There is a lot on Google Cloud Platform, and we totally acknowledge this, and we are working on it. We're making this bigger. There are 50-something icons up here. I talked about 43 individual products in this hour. Some of it was auctioneer call, and some of it was designed to help you make strategic decisions around it. I hope at the end of this, you now have a better idea of where you need to go in order to find the answers and solve the problems you want to solve. I am around. My Twitter handle has been on all the slides, so if you need to ask me a question, feel free to ask me a question. You will often also catch me out smoking, so feel free to do that too. And with that, I'm going to say thank you guys very much for sticking around and dealing with the logistic problems. And go get yourself some lunch.